Okay, so we are back again. As you can see, we just removed the tip, and Balázs just replaced it with the gripper, and within the gripper we have this workpiece already fixed. I just want to show you how it looks like because it is crucial to understand. So we have a kind of workpiece like this one. I think you can see this, yes. So this will be our origin. This will be our origin. This will be the x-axis and the y-axis later on. It's very important to understand that we have it in this position in the robot. I just show you from the near what we will do here. So this is the setup, how you can find the workpiece in the gripper. And what we will do, we will get this point. Okay, just try to make it sharp. This point to this virtual tip. Right now, Balázs is on with the free ride mode, and this will just come even more near to this point with the jog mode. And I just come back to the PC to show you why we are doing all this, so you will understand this then better. Here we have to make some additional stuff. So right now we will define this workpiece as a workpiece TCP. So what I'm doing right now, I'm adding an additional tool, and I just rename it workpiece TCP. You know what? I just make here workpiece TCP. Okay, that's fine. For this workpiece TCP, we will do the definition soon. An additional step, what I want to do before we start over with the TCP definition, that for the workpiece frame, I add an additional target, which must be called exactly how the frame is called. In my case, this is workpiece, so I just copy it and paste _0. Okay, so this is very important. If you call it blue, then it must be called blue _0. Okay, so this is very important. Additionally, for this point, we have to open the options menu, and we have to set it everything to 0, all the coordinates, except for the RX coordinate, which is 180. And 0 and 0, and you will see this later on why we need this. Okay, I just close it and save it. So, and right now we can come back to the workpiece TCP. So I just select as an active tool, and I'm just coming into the define TCP menu. And as Balázs already, with the first point, already got the position, we can just simply read out the position of the robot. We just seen on the screen it happened, and I just get the P1. Okay, we can move to the next one. Okay. Basically, this procedure is the same what we are doing with the normal TCP definition. So we stay all the time at the same point. This is always the same corner point, what we are using here. On different kind of angles, and we will just read out always the position from the robot, and we will just transfer it to our RobotDK model. So this is what we are doing. In this case, we will do this 4 times, because 4 points must be defined as a minimum. The more you can do, okay, we can move to the next piece. The more points you can define, the more accurate will be your results. So I can highly motivate you to go for 10, even 12 points, whatever. So the most you can afford, the better position or accuracy you will get out later on. And for sure, as at each definition of tools and frames, the higher accuracy you can do with the definition, with the initial setup, the higher accuracy you will get out later on by the processing. At this moment, this is not our approach that we want to have the highest accuracy. We want to show you how it works. Okay, I'm ready. And we are just coming to the fourth point, and we will not use more than 4 points at this tutorial to use this. And for sure, all the rules what you know for a tool definition are valid here the same. So the bigger circle or sphere you can touch up during the TCP definition, the highest accuracy you can get out. So this is
Okay.
This is no secret behind, and this is the last one. And right now I just hit the update button. I hit OK, and very important, save the file. So right now we have our workpiece TCP, we have the workpiece frame, and we have the workpiece target. Right now what we will do, we will come with the workpiece back to the wooden plate. And here I recommend you, if you can, that you want to hit the origin on the wooden plate frame. If you can't hit the origin, it doesn't matter. Which is important, we want to reach that the y and the x coordinates are exactly parallel on the workpiece to the wooden plate coordinate system. And may I help you?
Yeah, please.
Okay. So you can see, at least at this point, it makes sense if you have somebody who can support you. We don't have as much space here as we would need. So I just come here to this position and I just make it a little bit wrong that I can show you. And just wait a second, please, because I really want to point this out at this position, how it works. And please wait. I'm just coming with this camera to the near. So this is what I meant at the very beginning, that I can't hit exactly the origin with the corner because I don't have the space because of this metal part here. But it doesn't matter. But what is even more important, if you can see, if I can get it sharp, that the workpiece is right now not parallel on the layer to our wooden plate. So you can see that the one corner is already touching the surface, but the other corner is not on the same layer. And this is what we should align here. So I hope so that it's quite touchy. Yeah, we will let it so. And what is important, that the edge here is parallel to this axis, and the other edge is parallel to the other axis. Yeah, you can see. So this is my X, and this is my Y. And this is important to understand. So where you have to take care is really that the edges are parallel, the X and the Y, and the surface is really touching the surface as well. With this one, you can really make it sure that the orientation in the workpiece will fit to the virtual TCP on the stationary machine. It's very, very important and crucial to understand this. At this point, I try to come back to a kind of that you can see everything. Okay, it seems to be the case. And right now we have the position with the robot, and I just hit the get position. So right now again with the robot, I have exactly the same position in front of me like on the screen. Okay, it's very crucial, very important. So get position. And then we are just coming into the afterwork tools of Easy Automator. And here you can find the copy tool orientation from robot to a manual device. We just start this. And we just wait for, we will get a message where it will be asked which kind of frame we should use. And here you can see we want to copy from the wooden plate. This is very important because we were just working in the workpiece frame. But right now we have to select the wooden plate again, because this is the wooden plate orientation what we want to copy to the workpiece. And I just hit OK. And once we are ready, okay, here we have the message. The process completed successfully. So I just hit OK, and I save the station file again. Very important. After each successful step, you should do this. So right now on the screen, we should check out if the TCP of the wooden plate is exactly the same as the workpiece tool TCP. And to do so, I just hitting here the plus sign to get them a little bit bigger. And I'm just hitting this one that we can see here. Thank you. And here you can see that the workpiece TCP and the wooden plate, what is very hard to read at the moment, so you can see the workpiece TCP and the wooden plate TCP. This is just this little offset what you could see because I couldn't go to the origin. If I could really hit the origin point with my on the wooden plate with my origin point on the workpiece, then this coordinate system would be exactly at the same position. But you can see, so this is exactly the same orientation in each direction. So thank you for Balázs, because this was a great job. And we can move to the next point. We will define the home position for our processing later on. This home position should be quite near to the position where you will do the processing as well. Why it is important? With some devices, we have the problem that we do not have a config, and then the robot wants just to slip over. With this one, with this method, we can make it sure that with any kind of cobot, with any kind of device, we have a home position which is quite near to the working space working position, and with this one we can make it sure that with the linear movements we will be able to touch this point exactly there where we need this. So we are just coming to the workpiece frame. I just set it as an active one, and I just hit add target, and this target will be my home, and I just call it Elliot's home. Very important, you have to read out the position again. So you can see right now that the robot is getting to this home position, which was defined by Balázs. And very important, we just right hit this target, and we hit joint target. It is very important. This must be a joint, not a cartesian. This must be a joint. Okay. And no double click, no left click on this. Again, a right click and teach current position. So what we have done, exactly this position was read out from the robot into RobotDK. We just changed this home position to a joint position, and we just saved or stored exactly these joint coordinates into this target. And right now we should be, I think, ready to go for the next step. And I would recommend that we make a very short break here, and then we just come back how to move on. And I promise you, we are just so far away to make our first recording, and then you will see how the remote TCP recording is working. So